Hello good day viewers. In this tutorial we are going to learn how to evaluate the limit of absolute value functions, and we have two problems in this tutorial. Before we start, I would like to remind you something. Remember that if you have an absolute value of x, it is a piecewise function, right? X could either be what? Positive or negative. Depends on condition, right? X is only positive if x is greater or equal to 0, and x is negative if x is less than 0. So this information is very important in dealing with these limit problems. So let's start with the first one. We'd like to evaluate the limit of the function, the absolute value of x minus 1, as x approaches 1 from the right. So we have the limit as x approaches 1 from the right of absolute value of x minus 1. First of all, you should know that absolute value of x minus 1 can either be positive x minus 1, that is if and only if x minus 1 is greater or equal to 0. And it can be negative x minus 1 if and only if x minus 1 is less than 0. So this information is very important. So on the number line, suppose we have 1 right here. We want to approach 1 from the right hand side. So we have all values of x approaching 1 from the right, which implies that all of these values of x are greater than 1, right? So all x's are greater than 1, which implies that x minus 1 must be greater than 0 if you subtract 1 from both sides. So which condition satisfies this? Remember that the absolute value of x minus 1 is equal to x minus 1 if x minus 1 is greater or equal to 0. So we have x minus 1 greater than 0, therefore we are going to consider x minus 1. Therefore the limit of x approaches 1 from the right of the absolute value of x minus 1 is equal to the limit as x approaches 1 from the right of x minus 1. We are just going to consider it as positive. So from here you can substitute x equal to 1 directly. So this is equal to 1 minus 1, which is equal to 0. This implies that the limit of this function is definitely equal to 0. So this is equal to 0. And you can look at it graphically if you like. Remember that if you have y-axis and x-axis like this, the graph of absolute value of x is somehow like this from the origin. But the graph of the absolute value of x minus 1 will cause a horizontal shift 1 unit to the right. So at 1, this is 1, you have your curve like this. So this is the absolute value of x minus 1. So remember that the value of x is approaching 1 from the right hand side. So this is the right hand side. As you approach 1, it will approach 0 directly because this is the value of y at that point. And hence this is the solution to this problem. Let us take the second one. Alright, here is the second problem. We would like to evaluate the limit of the function, the absolute value of x minus 2 divided by x minus 2 as x approaches 2 from the left hand side. If we have a number line here and we have maybe 0 here, 1, 2, we are approaching this 2 from the left hand side, which implies that all values of x are less than 2. So x is less than 2, and if you subtract 2 from both sides, you have x minus 2 less than 0, which implies that x minus 2 is negative because it is less than 0. Therefore, we are going to consider this one as negative. So I can rewrite this as the limit as x approaches 2 from the left of negative x minus 2, because we have seen it is negative, divided by x minus 2. And x minus 2 will cancel x minus 2. We have only negative 1 left. So this is equal to the limit as x approaches 2 from the negative side, from the left hand side, of only -1. And remember that the limit of a constant is equal to constant, therefore this is equal to -1. And hence we say that this limit problem will approach -1 directly. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.